Now, the key to reducing fractions to lowest terms is the fundamental principle of fractions, which you might recall went something like this. If you have a times k over b times k, okay, a fraction, a times k in the numerator, b times k in the denominator, you can divide numerator and denominator by k and get an equivalent fraction. Of course, here we're assuming that b and k are not equal to 0 because we can't have division by 0. Okay, you can divide numerator and denominator, okay, by a non-zero quantity k and get an equivalent fraction. Okay, now this only works if k is a factor in the numerator and the denominator. That is, it's joined by multiplication here to a, it's joined by multiplication to b. Okay, then we can divide numerator and denominator by k and get a over b. We can also say we cancel out the k's. But canceling out is a form of division. And you had to have this kind of multiplication before so that when you divide, you get a over b. It is not true that a plus k over b plus k is equal to a over b. Okay? You cannot cancel the k's in this example because canceling is a form of division. And notice that the k's are not joined by multiplication, but rather by addition to a and b. Okay? If you have, say, a plus or a minus sign here, okay, then k would not be a factor in the numerator or the denominator. You cannot cancel out the k's. When it's joined by multiplication here, you can cancel out the k's. That is, you can divide numerator and denominator by k and get a over b. But it doesn't work here. Okay? This is wrong. Okay, now let me illustrate what's wrong with this with numbers. Sometimes when you see something with letters, it doesn't make sense, but when you see it with numbers, then it makes a lot of sense. Okay? If you had, say, the fraction 10/8, and you wanted to reduce it to lowest terms, well, you could say 10 is really 5 times 2, and 8 is 4 times 2. And in this form, it's easy to see that 2 is a factor in both the numerator and the denominator. We can divide numerator and denominator by 2 and get just 5/4. Okay, of course, most of the time we do this step in our head. We say divide 10 by 2 and get 5, divide 8 by 2 and get 4. But the important thing here is that 2 is a factor in the numerator and the denominator, and you can cancel out the 2's. Okay, now on the other hand, okay, nobody in their right mind would do something like this. Okay, 10 is 4 plus 6. 8 is 2 plus 6. Everybody knows, of course, that you cannot cancel out the 6's here. If you tried to do that, you would get 4 over 2, right? If you canceled out the 6's, you'd get 4 over 2, and 4 over 2 is just 2, right? And we all know that 10 over 8 is not the same as 2. Okay, we cannot cancel the 6's here. The reason we can't cancel the 6's is that 6 is not a factor in the numerator or the denominator. Okay, it is not joined by multiplication to the 4 and the 2, but rather by addition. And we cannot cancel out the 6's here. 2 is joined to the 5 by multiplication and to the 4 by multiplication. We can therefore cancel out the 2's or divide numerator and denominator by 2 to get the 5/4. Okay, you cannot cancel the 6's. Okay, these are just applications of what I had over here. Okay, here the k's do cancel. Here, of course, the k's do not cancel. Okay, now, while this may make a lot of sense with numbers, somehow when we mix in variables, people sort of forget the rules. Okay, let's see if we can keep them straight. Let's look at these two examples. X squared over x squared y squared and x squared over x squared plus y squared. In the first example, x squared is a factor in both the numerator and the denominator. Okay, if it makes you feel a little bit better, you can think of this as, say, 1 times x squared. And the bottom is x squared times y squared. We can cancel the x squareds. Okay, and in doing so, we would get just 1 over y squared. X squared is a factor in the numerator and the denominator. We divided numerator and denominator by x squared, and we get just 1 over y squared. By the way, even if the 1 was not present here, we would do it exactly the same way. The 1 is implied. When we cancel x squared Okay, that's really division by x squared. When you divide x squared by x squared, you get 1. When you divide x squared by x squared here, you get 1. So you get 1 over y squared. Don't think you get 0. Okay, even if you don't write the 1 is there. X squared divided by x squared is 1, not 0. And the answer is 1 over y squared. Now look in the bottom example. Here, x squared is not a factor in the denominator. It is joined to the y squared by plus, not by multiplication. Okay, you cannot divide numerator and denominator by x squared or cancel the x squareds in this particular example. Okay, you cannot cancel the x squared. This is as far as you can go on this particular problem. No further reduction is possible. No further reduction. This cannot be simplified any further. Okay, let's try some more examples. X squared minus 3x over 2x minus 6. Okay, now the first thing that should occur to you in this particular example is that we don't have any factors immediately present in the numerator and the denominator. That doesn't mean we can't get them, but at the moment, it is not in a factored form. You cannot cancel the x into the x squared because x is not a factor in the denominator here. You cannot cancel the 3 into the 6. Okay, 3 is not a factor in the numerator. Okay, before you can cancel, you have to have factors. Okay, you have to have this in a factored form, things joined by multiplication, not by subtraction or addition. Okay, so what we're going to do when we have a problem like this is to factor the numerator and denominator completely, and then look for factors in common in the numerator and the denominator that we can cancel out. Okay, in the numerator, we notice that both of these terms have an x in common. We can factor out an x, and we get x times x minus 3. This is x squared minus 3x by the distributive law, which is what we wanted. Now, in the denominator, notice that both of these terms, the 2x and the 6, have a 2 in common. We can factor out the 2, which would leave us with x minus 3 in parentheses. Okay, in the factored form, we notice that the numerator and denominator do have factors in common. Namely, they have the x minus 3 in common. Don't let this minus sign here confuse you, whereas the entire factor is x minus 3, and that is joined by multiplication to the x. Here we have this factor x minus 3. This is the whole factor. It is joined by multiplication to the 2. Okay, it's all right inside a factor to have a plus or a minus sign, but the entire factor is the x minus 3, and that is joined by multiplication. We have something like ak over bk. We can cancel the k's. We can divide numerator and denominator by x minus 3, giving us final answer of x over 2. Okay, let's try another example. X cubed plus x squared over x cubed. Okay. You can't just start canceling x squared into x cubed and things like that. You first have to put this into a factored form. Okay. We look in the numerator and we see that x cubed and x squared have x squared in common. We can pull an x squared out in front, and this would leave us with x plus 1. The denominator is x cubed. You can just leave it like that, or if it helps you can think of x cubed as x squared times x. Of course, you can leave it just in the x cubed form. Okay, now we see very clearly that numerator and denominator do have a factor in common, namely x squared. We can divide numerator and denominator by x squared, leaving us with a final answer of x plus 1 over x. And this is as far as you go. Don't think that you're going to improve on this answer by canceling out the x's, because x is not a factor in the numerator. You can't cancel out the x's. Some students cancel out the x's and they say 1 plus 1 and they get 2 or something like that. This is as far as you go on this problem. X is not a factor in the numerator and it cannot be canceled out. Okay, let's try this example. X squared y minus xy squared over xy minus y squared. Okay, if you want to try this problem on your own, you can shut off the videotape machine and come back to me after you've completed it. Okay, now, before you can do any canceling or anything like that, and it's very tempting, people want to cancel out all sorts of things here. Before you can do anything, you have to factor the numerator and the denominator completely. Let's look. In the numerator, we have x squared y and xy squared. Well, we see that they have xy in common. Okay? In the first term, we're left with an x, then take away. In the second term, we're left with the y. Okay, notice that this gives us, when you use the distributive law, x squared y minus xy squared, which is exactly what we have upstairs. Okay, in the bottom, we notice that xy and the minus y squared, they have a y in common. We factor out the y, and that leaves us with x minus y. Okay, now it's in a factored form, and we notice that x minus y is a factor in both the numerator and the denominator. That is, we can divide numerator and denominator by x minus y, cancel the x minus y's. And also, y is a factor in the numerator and the denominator. We can cancel that. And this leaves us with x over 1, or just x. Okay. The y's cancel, the x minus y's cancel. This is x over 1. Which is just equal to x. Remember, it's not x over 0. It is x over 1, and that is just x. Okay, for our next example, let's try this. X squared plus 3x plus 2 over x squared plus 2x. Okay, once again, you cannot cancel the x squareds. They are not factors in the numerator and the denominator, nor can you cancel the 2's. What you must first do in any problem you want to reduce to lowest terms is factor the top and the bottom completely, and then try to cancel things out. Okay. Now on top we have x squared plus 3x plus 2, and you'll remember from our tape on factoring that this can be factored into, let's see, we need two numbers which multiply to 2 and add to 3, and of course those numbers would be 2 and 1. This would give us, using the FOIL method, x squared plus 1x plus 2x, first outer, inner, and then last 2. So this is x squared plus 1x plus 2x, that's the 3x, plus 2. And in the denominator, we can factor out an x from the two terms, leaving us with x times x plus 2. In this factored form, we see that the x plus 2 is a factor in the numerator and the denominator. We can cancel out the x plus 2's and get a final answer of x plus 1 over x. Once again, I do mean that this is the final answer. You cannot go any further on this. The x's do not cancel. Okay. Let's try this example. X squared plus 6x plus 9 over x squared minus 9. Okay, in the numerator, we notice there are no common factors that we can pull out in front. Looking for two numbers which multiply to 9 and add to 6, and they would be 3 and 3. Giving us x squared plus 6x plus 3x plus 3x, that's plus 6x plus 9. In the denominator, we notice we have the difference of two squares, x squared minus 3 squared. And this can be written as x plus 3 times x minus 3. It's like a squared minus b squared is a plus b times a minus b. This is x squared minus 3 squared. So it can be written as x plus 3 times x minus 3. And here we notice that x plus 3 is a factor in both the numerator and the denominator. We can cancel the x plus 3's. That is, divide numerator and denominator by x plus 3, giving us a final answer of x plus 3 over x minus 3. Okay, for our last example, let's try this. X plus 3 squared over x squared plus 3x. Okay. Once again, before you factor, you cannot just start canceling out x's and 3's all over the place. Be very careful here. The denominator, x squared plus 3x, can be factored into x times x plus 3. Using the distributive law, we have x squared plus 3x. Okay, the top is already factored. It is x plus 3 squared, which is x plus 3 times x plus 3. You can either leave it in the x plus 3 squared form and then just divide the x plus 3 that way, or if it helps, you can write it out like this, x plus 3 times x plus 3. Okay? Either way, we see that x plus 3 is now certainly a factor in the numerator and the denominator. We can divide numerator and denominator by x plus 3, giving us x plus 3 over x as our final answer. And once again, no further simplification is possible here. You cannot cancel the x's. And this brings us to the end of the videotape.